Hey there everyone, Hitesh here, back again with another video, and welcome to the fresh new video on Kubernetes. I will 100% give it to you that probably some of you have tried to understand the Kubernetes or even to implement that. It is not easy. For a beginner, it is a really mystery that how the Kubernetes work, what is in the first place Kubernetes is, how it is going to make my life easier, or where should I get started to learn about Kubernetes. You have found enough of playlist in Docker, but Kubernetes is not that simple, and I agree with that point. But this video is here to change all of that. From this video onwards, you're going to learn a lot about Kubernetes, not from the theoretical perspective. All those diagrams and presentations are not there in this video. We're going to be directly jumping into Kubernetes, and one of the best way to understand something is to find out why it is there and what all it can do for me. So exactly what we are going to be working with that. We will be working on a full stack MERN app, and that app will be deployed using Kubernetes. The best part is you do not need to have that MERN app. In fact, we are not going to be writing any app. These are the containers which are available to us via official people like from Express guys and from Mongodb. So no code is being written and no code is needed to be downloaded from my GitHub repository or from my Docker repository. All of them are going to be coming up from official Docker repository. So yes, before getting started Kubernetes, you need to know a couple of more interesting stuff. First of all, you need to be aware about containerization. Now, I already have a really long video on the Docker. It's really a fantastic one. You only need to watch that before coming into this video. In case you are mildly familiar with what Docker is and what containerization is, and brief, vague overview that, yeah, it's a kind of a packaging of the application so that we can make images from it. That is also more than enough for this video. This video doesn't have too much of the high-end requirements. Only thing is you should be aware what Docker is, or basically what images are and containerization is. If you are ready for that, that's it. That's all the prerequisite is. So getting started with that, this video is going to be hands-on on building and containerizing a full stack application via Kubernetes. And we're going to see what all the bare minimum components which are required of Kubernetes. And instead of going into theories and just the definition, I thought this would be a great start of Kubernetes of let's just go ahead and get our hands dirty, write some commands and get Kubernetes in your system. Yep, that is what we will be doing. We will be talking about Kubernetes in AWS and Azure and all that maybe in the future. Right now, let's keep everything onto the local because that's where you have the most control. So with this, I hope you are excited about this. I will walk you through from the documentation and fire up your VS Code because I'm all excited to show you how we're going to be doing it. And one thing promised, this is going to be the most easiest guide of getting started with Kubernetes with the practical project, deploying a full stack MERN app using Kubernetes. Okay, all right, enough of the introduction. I hope you have already subscribed to the channel because I'm pushing out a lot of content, new fantastic easy way content. So go ahead, hit that subscribe and let's continue with that. Before we get started with the Kubernetes, I would like to thank the sponsor of this video, which is Rowy. Rowy is an open source, really fantastic and amazing tool for your backend. You can connect your database and build cloud functions. You don't need to go with the command line tools and all of that with the Firebase and stuff. You build your cloud functions directly in the browser with the use of Rowy. And forget about CLI configs and all of them. This is your database, you match them up, and that's what your Rowy is. I'll talk more about them in a minute. First, let's get started with Kubernetes. So a couple of things before we get started, I would like to introduce you to the hub of Docker. So this is where majority of the things are going to come into the picture. And the first one, obviously, we're going to be deploying a Mongo, which is going to be our database. So this is the database. And we'll be using any of the image, whichever you want. You can just go ahead and use that. Only thing we will be talking a lot is about the environment variable, because MongoDB at the time of initialization, it requires a root and the password so that it sets it up. So that is our first prerequisite or requirement we'll be getting. And then there is also an Express. This is something which is mind-boggling. This is super interesting. What Express guys did, they actually made an admin interface which connects to MongoDB, and you can do all the updates directly in MongoDB. And basically your web application is almost similar to that. Your web application also interacts with MongoDB, but in that case, you write a lot of business logic so that things happen like log in, log out, and all of that. But in reality, if you look from zoomed out version and a big picture of it, it just is an application which manipulates the database. So in this case, we'll be using Mongo Express as our web app. Now, it could be your own custom designed web app as well. It might have more environment variable than what it is available here, or less as well. But the big picture is that this is an application which interacts with the MongoDB. So it's the basic how it goes. Now, this is Mongo Express. We'll be using it. And by the way, in case you have watched the Docker series, I have walked you through with the Mongo Express in that also. So here we have list of table, what all is available and required. And of course, admin username, a password, and one more. There is one more, which is, I guess, a server. Somewhere here, this is the one. So server, admin, password, and admin username. These are the three which are compulsory in the case of Mongo Express. So these are the variables that we are looking up for. Now, obviously, this also needs three things. So you might have noticed Mongo server. This server is nothing, it's just a path of where the database lies. In case when you build application using Atlas, you provide that. When you build application using a localhost MongoDB, you provide that path in your application. So similar way, we have to provide this path to the environment variables. Okay, all right, this is all done and all clear. Now let's go ahead and see that how we can actually build up. So let's move on to Kubernetes first. Now, of course, the definition is a little bit challenging to understand, at least at this point of stage. Surely I'll break it down much more in the eventual videos, and you will be having absolute mastery of Kubernetes in over the time. Right now, this is really simple. It says Kubernetes, also known as K8s, and by the way, it's K8s because it's 1, 2, 3, 4, 5, 6, 7, 8. So between the K and S, there are 8 characters. Yeah, it's a really weird way of calling it as K8s, but you get the idea. It's Kubernetes. It's an open source system for automatically deploying, scaling, and managing containerized application. So one thing is clear, this is some kind of orchestration tool. Yeah, really fancy word, orchestration. It simply is simple way that you have containerized your application with the Docker. Now you have thousands of these Dockers. Maybe you have microservices or something else, or maybe just a one single application. Now you want a way through which these containers can be brought up, brought down. If somebody goes down, we need to bring it up back. And there should be a mechanism to control it. And that's what Kubernetes offer it. There's a lot more for Kubernetes to understand it. For example, why Google rolled it out as an open source now? Why not before? Google have been using this for so long. And it has something to do that AWS was taking over the market and Kubernetes is the way to get cloud free. So Google rolled it out. So yes, we'll talk about these interesting details and history later on. Right now, this is all what we have. And it's really simple, nothing too much. This is all what we got to do. And one thing is to note here that Kubernetes is mostly about microservices, but it doesn't always need to be. You can use Kubernetes with your regular application, but in the case of microservices, it makes much sense. We're going to go into documentation, and there are two keywords where I would like to bring your attention. The first one obviously is Kubernetes. And in order to work with Kubernetes, there are a lot of ways there we can work it through dashboard and APIs and command line. The one command line which is given to us is kubectl. It has nothing more than a command line interaction with the Kubernetes. So that's one portion. Remember, I repeat it again, that's one portion of understanding the Kubernetes. The another half portion is this guy which says minikube. Yeah, minikube is, yes, it is Kubernetes, but it's not kubectl. Kubectl is a command line interface to interact with Kubernetes. Minikube is a way to try, understand, and learn about Kubernetes. It's kind of in the Kubernetes, yes, I'll walk you through. It's a control panel that has a lot of nodes. I'll come back onto that in a minute. But the whole thing is very resource consuming. In case you want to learn that, you have to deploy servers on the cloud, which is not really ideal. It's not affordable for everyone. So that's why a singular application, containerized application is given to us known as minikube, in which all the drama that is supposed to happen in the Kubernetes happens in just one container. So remember, kubectl is the way to interact with that command line, and the minikube is like whole big Kubernetes things happening inside that, but given to us in a smaller form so that we can work out with that. Okay, so we'll talk about rest of the things, not right now. There are a lot of things in the Kubernetes, stateless, stateful, no need to just jump into them as of now. So let me walk you through that how does actually Kubernetes works and what's the basic overview, and definitely we'll come back onto this later one on another video. So the idea behind the Kubernetes is that you have this main control plane. So if I go ahead and write this one as control plane, there are a lot of names for this one, but we're going to call this one as control plane. And this control plane actually monitors a lot of further things as well. So let me go ahead and work on with that. So in fact, I can actually copy this and paste this and paste this. So yes, there could be a lot of them. So a lot of worker nodes are there and you can call them whatever you like. The idea is this is the main control panel, which is going to be controlling a lot of things. And into these smaller worker nodes, yes, they are known as worker nodes. In these worker nodes, all the control is being back and forth between the control panel. You never ever interact with these worker nodes because they just hold your application. All the commands in these worker nodes are being passed on through control panel. And yes, exactly, the kubectl is the utility which helps us to talk with the control panel. That's all we need to understand right now. Now, there are a lot of elements into this, that how the agents is being installed and all of that. We don't need to worry about. All the thing we need to worry about right now at this point is that we talk only to control panel, and control panel does this all worker nodes things. This is almost like I'm trying to teach you Kubernetes in such a way by saying that the sun rises in the east, and everybody knows sun doesn't rise in the east. Sun is always there, the earth is revolving, but we don't introduce that knowledge right now. It's not understandable. So exactly like that. The Kubernetes is nothing. It has a lot of worker nodes. We don't care about worker nodes as of now. We only care about the kubectl. So the kubectl, come on, kubectl. So this kubectl is the utility which is going to help us to just interact with the control plane. And that's all what we have to do. Okay, got it. Okay, we don't care about them, so let's go ahead and get rid of that. We'll just keep it 2 of them here so that we know that these are the things. Okay, understandable really at this point of time. Now we need to understand a couple of more interesting concepts which are there, and let's go ahead and work on with that. First and foremost, there is something known as config. Now, why this config is important? Because whenever we actually go ahead and talk about our application, we need to provide a URL to our application that here is a database link, you connect with this database and do all interaction there. It could be MongoDB, it could be Postgres, or it could be anything else. So in this case, my majority of the problem is that there need to be a DB URL that I need to provide. Now, in most cases, especially when you deploy your application on cloud and something, this is usually kept, this database is kept into internal network. So where our application is lying, internal network, the database is there so that the latency is low. So that is one of the challenge. Another challenge in front of me is secrets. Now, these secrets are also known as environment variables. Now, environment variable is something which is common for all developers. They try to point their application on certain port, certain key value pairs, like maybe they want to host things onto S3 bucket of AWS. So these all things are kept in the secret. MongoDB ID and password is also a secret. So I need to find a way that how can I keep all of them as a secret? So this is my another challenge before I go ahead and talk about Kubernetes and all these stuff. So this is my another thing. Now also, I need to talk a little bit about deployment as well. Yes, these are terms from Kubernetes. Deployment. Yeah. So this is the deployment, and deployment is really, really easy. It's nothing that is too much to be worried about. Deployment means simply take my application and just put it into a pod, or we saw that as a worker node. We'll come back onto these pods and all these, what these stuffs are right now. As of now, if we just understand that there is a wrapper around our container or our application image, somebody is wrapping a pod outside of it so that control plane actually can talk with that. That's all it is. So again, no need to repeat that again. It's just an image container on which we wrap around a pod so that control plane can talk to it. That's all what we do. So deployment needs to happen. And as you might have noticed, this deployment is great, but this deployment needs to happen for MongoDB. So I'm going to go ahead and say MongoDB, or let's just call this as simply Mongo. That is fine also. So this is where our Mongo is, and Mongo needs to happen, or we need to deploy the Mongo. That's what I'm saying as of now. So there we go. So we got this one, and this needs to have, I guess this, yeah, better. Okay, so this needs to be happen as a deployment. But there is another challenge that although the deployment has happened, But right now, this deployment is not talking to anybody outside. In the MongoDB, there is a port open. Same goes for Postgres as well and MySQL. There is a port that needs to open so that at least the people who are internal in our entire cluster, or maybe a VPC, whatever it is. So in that, somebody should be able to talk to MongoDB. And also, if I want to find out, hey, MongoDB, what's your name? What's the URL? Where should I access you? That is not also like opened up to the world. So for that, there is another term which Kubernetes actually gives us, known as service. Now, service is nothing much complicated. Deployment is super easy. We just put that container and make it available. Service allows us to actually take that deployment and make it available to the world. World would not be a correct term, to at least the organization that we are having, the internal network that we have. And this service exposes all the port in case you have. So this is the job of there. Okay, so let's go ahead and do that connection as well. So there we go. We have a deployment and a service. Now, during this deployment time only, we tell the MongoDB that, hey, what are your secrets? So this somehow needs to be linked with the secrets. So that's why we keep this config in which the DB URL comes up and secret at top. So these are almost like a global variable and anybody can refer to them. I hope this is now making a lot of sense. If service wants to sometime refer to these secrets, they can, because they are kind of a global. If service wants to check or refer something from the config, yes, they can, because they are sort of global variable. Now, same thing needs to happen to our application as well. So let me just go ahead, copy and paste that, and let's go up here and copy that, paste that here. So same thing needs to go and happen to our web app as well. Let's call this as web app, but it could be anything else as well. So this is our web app. There we go. So the beauty about this is that once I understand that how the deployment of MongoDB is done, I can actually go ahead and replicate all of this for the web app. Of course, there might be some environment variable that might change. Of course, the image from the MongoDB, I have to use a different image. But you get the idea that it's not too much drastically different. And same goes for service as well. In the case of MongoDB, I was opening up the port of MongoDB so that the world can actually go ahead and see that. But in the case of web app, I have to actually go ahead and open up my port where the application is listening. In the case of React app, like 3000 is the most common number, but this is something we need to say. And also this web app needs to be aware of MongoDB, that, hey, where can I find MongoDB? What's the URL of it? What is the ID password to interact with that? So again, yes, the point of environment variable also comes up, the secrets. So that is what the basic is. Now there is one more last thing that comes up, which is something known as node port. This is a really interesting thing in the world of Kubernetes. Right now, all the thing that you are doing, so let me go ahead and show you that. So right now, all the things that you are doing in the world of MongoDB, this is happening internally. This is happening all inside. So far, the external world is not aware of it and cannot interact with that. For that, an additional service is being offered by Kubernetes, which is known as node port. It's really just a flag that we have to enable. Now, this can go really deep and we can just do an entire long video on that. But this is the basics of how it is being done. So if I go ahead and wrap this up inside this one, the node port is actually something which makes it available for the outside world. And that is, yes, of course, we want to do that. Now, we don't want to expose this entire application to the external world. We simply just want to go ahead and export this web app to the node port so that people outside can actually interact. Now, notice here, so far it's looking complicated, but the advantage that Kubernetes gives you is, notice right now, let's just say we have one of these container as MongoDB. Usually that's the ideal case. And this is my worker node for the web app. And let's just say a traffic comes up for this web app. This entire deployment and service, within just 1 or 2 lines of change, I can just go ahead and replicate it. Now, half of the traffic will be managed by this. And if I wish more, I can just go ahead and replicate this. And this will provide me a zero downtime. I can roll updates to my application. And even I can handle my traffic without worrying about anything, just changes or configuration changes in the file. So good, so good. And I'm pretty sure this is looking a little bit, tiny bit complicated as of now, but it is not. All we got to do is work on with the secrets, work on with the config, And we'll be working with deployment and service one time, and then we'll be just copying and pasting it for web app also. So this is the advantage of knowing the things once. You know the deployment once, you can deploy it for MongoDB. Same ways you can go ahead and deploy for web app or maybe Postgres or maybe MySQL. Same way, the way you are exposing your services or your ports in MongoDB, same way you can go ahead and expose them for web app or maybe any other app that you are building in Spring or maybe C#, whatever you like, you can go ahead and do that. So this makes things easier. Now, yes, I understand I have actually opaqued a lot of information from you about Kubernetes, its control plane, services offered and APIs and all of that. I don't want to bog it down as of now. I will surely do it in the upcoming videos. Right now, it's important that we understand this much only. So quick summary before we get into practical part. We have kubectl, which helps us to work with the control plane. Control plane is the mastermind, which helps us to interact with a lot of worker nodes. This is a big picture overview of the worker node as of now that we are doing. So we can have a MongoDB and deployment services for one. We'll be having web app as deployment and services for one. Some global variables so that secrets can be tagged. And we also saw that yes, we need to install Kubernetes, but we also need to install minikube to perform these experiments or exercise. Before we move forward into the course, I would like to thank our sponsor Rowy and would like to introduce a brief overview about the Rowy in this video. So first and foremost, Rowy is available on GitHub. You can just check out them onto the GitHub, give them a star, and show support to these amazing open source projects which are helping a lot to the developers. And again, open source, that means they have earned the trust that how this is all working. And there is a guided deployment that how you can work with that. I'll show you in some other video later on. But right now, let me just walk you through what this is. And this is clearly mentioned on their website. What they do is they actually allows you to interact with your database, especially with the Firebase, in a much easier and nicer fashion. For example, we all know that the database given to us by Firebase is super powerful, don't get me wrong, but the visual aspect can be improved a lot. So as you see up here that it offers a lot of 30 types of fields which you can select from the Firestore. You don't need to just select these fields or add these fields from the code. You can just do all of them here. And by the way, the support for MongoDB and Postgre is also coming up nicely. And then you can just stay on to this. And now all of this is going into Firebase. And notice here, then you can just write your cloud functions directly. And notice here, they are using here the convert SVG to PNG. You don't need to install it. It's already there. They'll take care of all of this. You just worry about writing your functions itself, and whatever the npm packages, APIs, what you want to use, they'll just magically take care of that. No magic, you can read it into their GitHub as well. And this basically is what they do. And again, I highly recommend to check them out. They're really kind enough to help me to keep making more such awesome videos. And again, go ahead, check them out. In case you need any help, reach me out. I'll make another video just on Rowy so that you can understand them a little bit better. Now again, let's move back on to the content. All right. So this is all what we're going to do is first and foremost, I need to make sure my Docker is up and running. So I'm going to go ahead and understand the Kubernetes first, and I'm going to go for the installation part. Let me just quickly go ahead and see that where the installation part is. Here it is, getting started and learning environment. This is exactly, it says install kubectl. And again, go ahead and install the kubectl for Windows or maybe Mac, or maybe if you're in Linux, go ahead and install that. So for Windows, it's really simple. You can use Chocolatey or Scoop, one single line of installation, or you can download the latest release. There are a lot of options available. All we got to do is make sure we have this Kubernetes CLI, which we call as kubectl installed. All right. Now, before you go there onto that part, let me also tell you one more thing, that in order to make sure you have minikube and all these stuffs, in fact, let me just go ahead and show you that when we come onto the minikube part. And we can also go ahead and install this. My system also don't have it. So I'm going to go out into Apple Silicon, and I want to install it with the easy way. Just like there's a Chocolatey, I have a brew install kubectl as well. I'm going to go ahead and copy this. Let's fire up the terminal. And I want to say brew install kubectl. Now this obviously is going to take some time. Probably I need to pause the video or something. But in the meantime, I would like to also bring you towards another thing, which is minikube. Let's go ahead and talk about. So it says, hello minikube. And this is where the minikube is. And you can have the minikube dashboard. Let's go ahead into getting started, learning environment. Of course, we are learning. Whether you go for, let me just close this because we don't need this now. We'll check for Mac and Windows. And in both of them, you are going to notice that if you look for that, hey, what is this kubectl and all of that, it requires some kind of virtualization or containerization. Why I'm telling you both in a different way. The way how this minikube works, it gives you an entire environment in which the control panels and the worker nodes and as much as you want to spin, you can have all of it. But it cannot just do it magically. It needs some kind of a virtual machine or a containerization environment. The best one which we have seen for the experiment purpose and what I've personally gone through with my laptop and stuff is the Docker environment. So if you have Docker installed, that means yes, all the requirement and prerequisites are done. So I'm going to go ahead and fire up my Docker. And it's going to take just a couple of seconds to fire up my Docker. There we go. Don't need tips and all of that. And it's going to just take a Docker starting. Now, as soon as the Docker starts, the ideal situation says, then only you should start your kubectl and minikube and all of that. These are some of the ones which are from the previous one. We don't need to worry about that. Now, let me show you one more thing. In the settings, if I go ahead, notice here the Kubernetes is there and you can enable the Kubernetes directly from here. We don't want to do it. We don't want to do it. We simply want to keep this up and running so that it shows up at the top that, hey, Docker is up and running. And that is all I need. I need to have a Docker installed. So we're going to go ahead and cancel that. And we're going to just close this one. Let me bring up my terminal. So where is my terminal? There we go. This one is probably going to take some time because the brew is right now installing and updating. So let me go ahead and pause the video that in the meantime, it just finishes up all the update. Otherwise, we'll be sitting here and talking to each other. Nothing fruitful. So let me go ahead and pause this till the time kubectl install. And then together, we're going to be installing the minikube as well. That is also a long process. All right, so yes, it took a little bit while to install it. But yes, we can see that it got installed successfully and everything went okay. Now, same thing happens for you as well. Maybe you have configured Chocolatey, Scoop, wherever you work on Windows. So this is all done. Now, the next step obviously is to go ahead and install the minikube as well. So let's go ahead and find out. So this is kubectl. And let's go ahead. This should be minikube. Not here still. Let's go on to Kubernetes, documentation. We want to install the minikube. Hello minikube, getting started, learning environment. And we want to install it on the Mac, but you can go ahead and follow the guide for Windows as well in case you are on Windows. It's really same. And again, if you're facing installation issues, we need to check out a lot of your skills as well as your power determination to learn a new topic. Installation problem is common. Okay, so brew install kubectl. We need to have the minikube as well. This is interesting. I saw this command. I saw this. Okay, so, all right. Not able to see. Install minikube. Yes, I want to learn that. And there we go. To start your cluster, we have to go with that. So I am on Mac and I want to install through Homebrew. Brew install minikube. Yep. Really simple command, but I wanted to show you through the documentation. So let's go ahead and remove that. Brew install minikube and hit enter. Now this obviously is a long installation. It is a little bit of a resource consumption installation as well. It requires a little bit of the resource heavy on your system as well. But these kinds of installation permission, this time it was fast. Probably my internet was a little bit faster, but this is all what we need. Now we won't be running any command as of now. The max that you probably want to try is just having a kubectl and --h or help. And probably my bad, it's just help. And you can see all of that. If you're getting a long list of this, that means the kubectl is properly installed. You won't be finding any minikube command as of now. That's an environment, so it's not a command line utility that you can find a lot of options on it. Yes, it has some options, but we'll talk about them later. Okay, so let's go ahead and remove that. All right, so we're going to be keeping this documentation handy because we'll be cheating a lot through the documentation. I don't think that should be called as cheating, but still. Okay, let me go ahead and fire up my VS Code. Here we go. And also let me create a new file on my desktop. I'll push this file onto Git as well, probably, or zip it, throw it to you as well. And we're going to call this one as MERN. Not really a creative name, but you get the point. MERN. Okay, let's talk about them one by one and you will be understanding. And the best part is you will be able to replicate this entire knowledge anywhere that you want. Okay, all right. So the first thing that we are going to learn about is secrets, because we are worried about the secrets the most. These are almost like environment variable. And the way how we are going to be doing it and the way how everybody does it in the world of Kubernetes is writing them in the configuration file. The configuration files can be written in YAML or JSON. I prefer my configuration to be in YAML. It's much more easier to read, less line of characters and less mess around in that. And in case you don't know about YAML, I have created a video already. Go ahead, watch that after this video. But right now it's really simple. It's just you'll be able to understand everything. I'm going to be calling this one as secret, and feel free to call it whatever you like. I'm going to call this one as secret .yaml. That is the common syntax, but the secrets, if they are particularly associated with MongoDB or Postgres, it is common to see this as MySQL dash secret or something like that. I'm assuming that MySecret is not closely related to just Mongo. Although it is advised that you should create separate files for MongoDB secrets and your web app secrets and all of that. Right now, I don't have too much, so I'll just call this as secret.yaml. Again, now you know the better conditions and best practices, so you can go work with that. Okay. But I don't know how to write the secrets. That is the problem. So let's go ahead onto the web and call this one that, hey, how can I write secret? I'll search for it. And let's go, oh, not on minikube. I wanted to be on Kubernetes. Yeah, I want to search is secret. And secret, come on, I can write. Secret, there we go. And this whole page is going to walk you through that how you can write the secret. So there's a lot of ways how you can write secret as environment variable, using secret as file from a pod. So there's a lot of ways how you can do it. So notice here, this is how they write is we can actually go ahead and study this a little bit. This whole thing is just basic. We don't need to worry too much. This is a metadata and stuff. And then we'll definitely use this, that you can provide your environment variable like this, a dash, that means an array. The name, what is the name of your secret? And then value from, you can refer the value from secret key reference, and we'll be using this. So this is one of the many options that we have. But if we scroll around, there's a lot of ways how you can actually go ahead and do this. For example, a lot of metadata specs, a lot is there. So I'm going to go ahead and say that use case, I want to use case a container environment variable. So this looks interesting. So API version, then a secret, then the metadata is there, then type opaque. So you can research a little bit. There are a couple of types how you can mention your secrets. Opaque is the best one. Nobody can see it. And the only thing you have to additionally do in the opaque is provide your username and password. That means the keys and values. Key could be clear text, but the value needs to be encoded as base 64. Yes, not the securest one, but the purpose is different here. Purpose is different, so we're going to be using that. So all the values that needs to be converted into just like that. So let's just go ahead and copy this, and we'll go back onto our code editor. We'll be pasting it. All right. So this looks good. API version is good. Kind is secret. Make sure this is exactly that. This is important. And we're going to be calling this one as, it's a Mongo secret. We have not much. So we're going to call this one as Mongo secret, MySQL secret, or just secret, whatever you like. Hey folks, this is a side note that I made a small mistake. So in case you don't want to repeat along with me, although I have walked you with the debugging process, notice here in the secrets, I have actually mentioned a metadata as mongo-secret, but accidentally in the files like Mongo app, I have, wherever I'm explaining you this environment variable, I called this name, where you have to give the file name. Actually, it's a configuration name. So I have just mentioned a secret. So make sure you edit that as mongo-secret, only in the file name. That's it. Let's catch back. Type is opaque. That is fine. Now let's go ahead and provide a username and password. All right. So the username for the Mongo, I'm going to be calling it as Mongo user, Mongo password, really common for all the tutorial. Why? Because it is mentioned in the documentation. Okay, let's just go ahead and say that base 64 encode. And there we go. This should help us to convert that. So we're going to call this one as Mongo user. Feel free to write anything that you like. I would say encode, and this is the value it gives me. I'll copy that value, go back, and I'll paste this value. Now it is base 64. And we're going to call this one as Mongo password. and encode that, please. And this is the value that I got. Now, in case you want to keep your password something different, which I highly encourage you to do, go ahead and change that. Now, I have put the Mongo user and Mongo password in a file so that I don't have to remember it again and again. I can reference to this file variables and can use it again and again. Now, calling them as a capital username or capital password is totally up to you. I'm going to reference that a little bit different. So I'm going to call this one as Mongo user. And this one is going to be Mongo-password. I think we should keep a little bit consistency here. Mongo-user would be great. Doesn't really matter, just a variable name. So there we go. Okay, let's go back. Let's see that where we are right now. So the problem of the secrets is gone. Now I do understand, and I can definitely inject more secrets into this one. Again, the ideal definition guide is keep all of your secrets separate. So your web application secret should be webapp-secret.yaml, mongodb-secret.yaml, postgres-secret.yaml. So separate files are always a good idea. The next thing is config. This is where things actually happens as a magic. So what is this config? So let me show you by reading the documentation a little bit. So there is something known as config map in Kubernetes. So what is this config map? The config map is an API object used to store non-confidential data. So this means the secret should not be here. It should be non-confidential data. Pods can consume config map as environment variable. Great. Command line argument or as config file. This is what we do. Okay, one more line, just one more line. The config map allows you to decouple environment specific configuration from your container image so that your application are easily portable. So what it does is, for example, let's just say right now you're hosting your entire database within the Kubernetes. But let's just say one day you decide you want to keep it outside of Kubernetes or maybe someplace else, maybe MongoDB Atlas. At that point of time, these config maps makes your life so much easier. And yes, there are examples as well using config maps and immutables and using how to use config maps and all that. A lot of examples are given up here that how you want to use it or how you can actually go ahead and use it. So basically what we're going to do is, let's just say config map as an object. We are going to be using this one. Feel free to copy anything. It doesn't really matter. I'm going to just copy till the data, copy that. And we're going to create a config map file. So let's just call this one as Mongo config. Again, the advice is same, Mongo config.yaml. And paste it. Again, it's not compulsory to call it as config for Mongo only, but it could be called for any database or any web application as well. The idea behind it is you're going to see mostly available, this config file is available to only for the databases because the database today is in Kubernetes. Tomorrow, it might be a standalone entity. So that is why it is important. Now, I'm also deliberately skipping some part. There is something known as stateful and stateless of the application. Yes, I'm deliberately skipping that. Otherwise, the tutorial will not make sense much to you and will not be easy. We'll talk about them in later on. So right now, this is version 1. Config map is key and very important. Just like here, the secret is important. This is a kind of file. The file is not determined based on the kind if you call it as config or secret. No, you can call it superman.yaml. The way how you define the kind here, that is what makes the file, the type of file that you want to interpret it as. Now metadata, we call it as game demo, but we're going to call this one as mongo-config. Feel free to call it anything. Now inside is the data that where actually should I find this? So again, I told you these are configuration file. So MongoDB right now is here. It could be in the Atlas later on. So what we're going to say is in this one, we're going to say, hey, this is my mongo-URL. Now this URL could be outside or this could be Atlas. Right now we have nothing. So we're going to just keep a remark for ourselves as come back here. Because right now we actually honestly don't know where the Mongo URL is. Why we don't know about this? Because the URL will be given to us by MongoDB. The moment we are going to deploy the MongoDB and we are going to open it up as a service, then the URL will come to us. Then we'll come back and we'll mark that as a MongoDB URL in the config. Now again, you might want to deploy that as here as of now, but later on it might be having a different URL, different service that might be exposed. So depends and based on the use case scenario. So we cannot do anything right now. Let's just move forward and try to deploy the MongoDB. So deploying the MongoDB is really, really simple. So let's go ahead and work on with that. Let me get onto code part. There we go. So we're going to call this one as mongo-app.yaml. Feel free to call it anything. This is my Mongo app, and I will also have a web app. So that's why I'm calling it one. Now, notice I told you that we need to actually deploy this. So yes, this is also another kind. We need to search for deployment. And as I told you, deployment is something which once you learn, you can replicate that. So deployment. A deployment provides a declarative update for pods and replica sets. I'll tell you what this replica set is. Simply, you describe the desired state in deployment, and the deployment controller changes the actual state. What it's saying, you just tell me how many pods you need or how many worker nodes you need. You don't worry about it. I'll make sure it happens and it works. This is the best part about it. And we'll see that how the use case actually works. There are a lot of names here. I'm pretty sure you can go ahead and read a little bit about them. What I'm worried about is how they actually go ahead and deploy an Nginx so that I can study it and I can replicate it for my MongoDB. I can just go ahead and copy this, copy it to clipboard, go back onto my VS Code and paste it. All right. First of all, a lot of spaces. Is this? I think I'll copy this from here because that's actually giving me a lot of spaces which I don't want. And I'll paste. Much better, much more readable. Okay. So here the API version, it says apps v1. Okay, so we're going to keep it as it is. So that's what we have copied. It's a deployment type. Secrets, config map. Yep, we have a deployment type. Then we have a metadata which says the name and it says Nginx deployment. And it's also providing a labels, calling up as a key value pair app as Nginx. Okay, so far clear that I'll name my deployment something and I'll provide a label for it, and label has a common use case. In case you are familiar with development, label is something which you can keep on referring for in a different part of your file to the same values. So yes, I get the idea of that. Then it says spec or specification. Replicas, how many replicas you want. Remember, I told you in here that you can have as many replicas of this web app as you want. And this deployment is taking care of it. 1, 2, or 3. Here it is saying 3. I want that my MongoDB should be just 1 because right now we are not much aware that we want to use the same volume, multiple database, some information might be here, some not be. Yes, there is a solution of that as well. Right now, we don't want to get into that. Then it says selector. So match label, match the label of app, which is Nginx. So yes, I get that idea. Then it says a template. Okay, interesting. Template also has a metadata which says labels. So labels are being used a lot. We need to study the labels in a dedicated video. It says app Nginx. So yes, I get that this app label is getting repeated a lot of time. And then inside the template, there is again a specification. Remember, I saw the spec here. I saw the spec in line 16 as well. And I see that, hey, this is the container. This is where the information is. So I told you that container is your image and we are wrapping it around with a pod so that our control plane actually can talk about it. So rest of all the information about above the spec is all just a wrapper so that it can multiply it or it can reduce it. Get the point. So here you just name your container, provide an image, and just open up a port for it. Cool. We can actually go ahead and do it. So let's try to deploy the MongoDB with that. So we're going to go ahead and move on to hub.docker and we'll see Mongo there. Let's see. Hey, Mongo, we have a lot of versions of Mongo. If we go ahead into tags, there are a lot of versions of Mongo. Now the 6 is really popular, but we have a 5.0.13. Feel free to use any MongoDB or even the latest version 5.0. We're going to be going for 6.0. What do you say? Or we have anything latest? We can go for latest as well. Let's go for 6.0. That should be fine. Or we can go for latest as well, but let's go for 6.0. Okay, let's start with the top by manipulating it. I don't want to call it as Nginx. I want to call this one as Mongo or MongoDB deployment. Mongo is fine. And I'm pretty sure the label should match everywhere. So the labels here, app Mongo, app Mongo, app Mongo. The name should also be Mongo. It should be same and consistent everywhere. Okay. So one problem is solved. The metadata, the labels is consistent. The replica is 1. The selector is always going to match. So if it wants to have multiple of containers from this template, it is going to match the label of Mongo to keep a track or maybe increase, decrease, whatever it does behind the scene. And I also have this one being sorted. Okay, good so far. The spec, we are mentioning the container as Mongo. So obviously we should use a Mongo image. So we're going to say that, hey, Mongo. And then simply we have to mention the image. So it could be any image. You can go ahead and say, hey, this should be latest. This should be 5. This should be 6. Whatever makes you happier or makes your application happy, we want to go with that. Now, we also are quite familiar and aware that MongoDB don't need port 80. It needs a port of 27017. In case you don't know that or forgot that, you can always go into overview and look at quick reference and all of these that they obviously mention it somewhere here. Let me find that. 27017. So there we go. Connect to MongoDB from another container. You have to make sure that the port is open. This is such a common information that you'll find it almost everywhere for Mongo, for MySQL, for Postgre, for almost everyone. All right, so this is good so far, but we also saw that this is not enough. MongoDB requires some of the more information, especially the environment variables. So we need to figure out that how the environment variables are being done. It's really, really simple. We just saw that how environment variable works. I will save your time. Instead of going back into documentation, I'll just copy this and I will provide you that. We just studied it. In fact, I'll show you that we're going to go for secret. And let's go for secrets. And we're going to say that I want to have a use case of visible to one, not visible, container variable. There we go. So notice here in the container, we have this name, not here. We should be having it somewhere. We just saw it. And let's just say secrets. It takes sometimes a little bit time to find out. And we have to provide it as, let me find that. And env. And we have 0 matches for this one. Using secret as variable. Yeah, here it is. So notice here, we can remove this now. We have this environment, and this is exactly in the container. So just like we have the name, image, we have this environment, and we can provide all these values. So optional is false. We're not going to copy this. Let's copy this and try to read it. So we have opened up this container, but we also need to send some of these key value pairs as environment variable. So let's go ahead and hit enter. And this should be right in the indentation level of where the ports and everything that you have mentioned. So we're going to just keep it there. And obviously this is going to create a problem for us. So we're going to go ahead and provide this up here. Let me just indent them. All right, long videos take some time. Okay. Let me just indent them. So notice here, I told you that inside the container, we are providing the name. That is correct. The indentation, look at the indentation of the name and look at the indentation where the ports are. So inside the container, we are providing this name and all of these things. Similar to that, we should also provide, like, the port is being provided, the environment is provided. But the problem is ports and environment are at same correct indentation. This one is not. So just select all of them and press Control and the square bracket or Command and square bracket. It will move the indentation. Small hacks, but you should know about them. Okay. Now, the first thing is environment name. Let's first sort this out by going up here. It requires this one. We actually copied the wrong ones in the Docker example. I updated it later on, but I hope you remember that. So we're going to just copy this, paste that. Okay. So my variable name is Mongo initial root username. Okay. Where should I get this value? You should get this value from the secret key reference. And yes, there is a way of getting a reference from config map file as well. Remember, the kind is always defined from here, config map. So here we are saying secret. So secret, we are saying, hey, get the value from secret key reference. So this is how the Kubernetes works. Okay. We're going to get that. And now all we got to do is provide the name as well as the key value. The name is the name of actually the file. So we have called this file as not as my secret, but just as secret. That's all. Whatever the file name is, go with that. All right. What is the key that you have used? In the secret, I have used the key of Mongo user. Okay, I hope that's a very replicable information. So use this key. That's all. That's all we have to do. So notice here, I was able to tell all of this from the secret. Nobody knows it now. All right. So this is the first environment variable that we have given. Now we need to obviously give a second environment variable. So just duplicate this and we need to go back here, password, copy that. And here is my password. Take the value from secret key reference. The name of the file is secret, and that is why we call them as Mongo secret, web app secret, Postgres secret. So it is much more clear in the spec file. Now, after this, we're going to go ahead and say, hey, what's the key that you have used there? Okay, I can tell you that it's the Mongo password. All right, Mongo password. All right, so this is the basic. This is all what we got to do is have this one. All right, so I hope you now are aware that so much we have achieved. Secrets, config, we don't have this DB URL. We'll get that later on. MongoDB, the deployment part is done. Let's go ahead and work on with the service part. And I told you that this service part and deployment thing is common for Mongo. So there are a couple of ways how this is being done. The first one is easy. You go ahead and triple dashes, and then start writing your services file here. This means the break of the YAML file. Or sometimes you're going to see in bigger of the companies, bigger scalable products, that these are kept as a separate one. But in that case, the naming convention is also very clear and in a folder as well. All the secrets of Mongo goes into one folder, all the config goes in one folder, all the deployment related information goes in one file and in one folder, and the services also go there. But we're going to keep them as, it's a small app, so we're going to just keep them in one file, but feel free to keep it in another file, no problem at all. The common convention is to keep them in the same file. Let's go ahead and see what's there into service. So the next, notice here, the service is remaining. So here is a service. Okay, let's see and study what the service does. An abstract way to expose an application running on a set of pods as a network service. Okay. With Kubernetes, you don't need to modify your application to use an unfamiliar discovery mechanism. So what happens is in the Kubernetes, the pods keeps on dying and Kubernetes get them back. Now, when the pod gets back up, it gets its own IP. And every time finding that IP could be really challenging. So for that, the services actually comes into the picture. Once you enable or stick a service to a pod or to a configuration, it simply says, hey, if the pod dies and come back again, I'm really not worried about. I just talk to service. Service discover the pods and all these things. I don't really care. That's what exactly it is saying. This probably might be getting you that, yes, I'm understanding Kubernetes now, but I need to dive deep into theoretical part as well. Yes, we'll do that as well. Now, Kubernetes give their pods on IP address and a single DNS name for the set of pods and can be load balanced. So yes, theory is required, but you get the basic idea that a service is required for deployment so that we don't hunt for IP and all these things. And this is basically your service, really tiny and cute. And this is what we'll be doing. So there we go. API version, we don't care. We copied it from the configuration as the Kubernetes says. Important is the kind. So yes, this is a service. The metadata, whatever you want to call this one as, you can call it as my service, Mongo service, whatever you like to call this one. I would simply like to call this one as Mongo service. That would actually make sense. Mongo dash service. This reminds me something that, hey, we didn't actually fulfill the config here because we didn't know the Mongo URL. And now we are now aware of the service that, hey, it's not the IP that I have to hunt. I can just refer here as Mongo service and it will be available. So yes, that's the name of my service. And as the config file, you just go ahead and look for Mongo service. Told you, really simple, really easy. Now, in case any other application is also looking for some URL or some way to interact with that container or the service, you can use the services here. All right. Now, spec is selector. What should I select? Now, in this case, we are going to select based on the key value pair. This is really interesting and something that you should know. Now, notice here, right now, this could be in its own separate file. So it has no idea that, hey, here in the diagram, you're telling me that this service needs to be attached to MongoDB deployment. But right now, this is a standalone file. It has no idea how should I do that. In that case, these selectors are useful. And we actually worked on these selectors here. selector match label app Mongo. So we should call this exactly that. So we're going to call this one as Mongo. So hey, now you're attached, this service is attached to the deployment, which is of Mongo. And the ports. On which port you want to interact? Yes, of course, TCP, but we know that the target port, this is the target port container. Copy that and paste that. So if any application wants to interact with that, I told you again many times, your application container wrapped around some of the functionality pods, and now it can interact. So from inside, you have said that, hey, everything I'll do is on port 27017. Outside, you're interacting with that, but for the world or for your application to interact, you need to have the same port. Now, it's not compulsory to same port, but your application, usually in the database, connect with that. But you can call this any port that you like. No such compulsion. Having same port, good thing, but you can change it. So notice now I am completely aware that how can I actually bring this up? Pretty easy. In case I have any of my other image, I can just change this image. Very repeatable task that I have achieved. Okay, so you have achieved this much: Mongo deployment service, Mongo web app, and all of that. Now the next thing that is in front of me is deploying my web app. Now your web app could be any app that is deployed on Docker, maybe your container from AWS, wherever you like. I am going to deploy a web app which is Mongo Express. And I'm going to be using this Mongo Express for that. And for this, what I can do is, this is my Mongo app, but now is going to come up is my web app, web-app, of course, .yaml. And I hope now you can already see that coming, that this is almost like a replica, except this node port, which we are going to talk about that. But this is a repeatable information. If it is a repeatable information, we can actually go ahead, copy this and paste it into web app. Yep, that everybody does that. All DevOps do that. But it's not like the mindless copying. We obviously go ahead and study it and do this one. So we already saw that metadata, it should not be Mongo, it should be web app. So that actually makes sense. So if this label is a web app, the label should also be a web app. So we are calling it as web app deployment. Let's call it as web app. The spec, how many replicas you want? 1, 2, 3. All of them are going to be connected to the same database. So load balancing can be done with just by changing a number. You get the idea how this could be done. I'll keep it 1, but you go ahead and try it, play with the 2 or something. Selector, how should we select with that? Select with web app this time. Match the labels of web app. In the template also, the metadata label should be calling it as web app. That should be done. Here comes the container. So container wrapped around the pod is wrapped around the container inside. Yep, that's exactly what this is. We're going to call this as name as Mongo-Express. And we're going to be using the same thing here as well. So we're going to call this one as Mongo-Express, and we'll be using a latest. Really don't care which one you use. All right. The port. Now this application actually doesn't run on any port. We need to see this port up here. So if I go up and look at here, this actually is a application which runs on port 8081. So I have to open up that exact port for this application, which is 8081. Your application might be listening on port 3000, 4000, which one makes sense. Now I have to provide these environment variables. All right. So we know that a couple of environment variable needs to come up. So let's go here. The first couple of them is, obviously there is a Mongo config server. This is something we haven't seen, but this admin username and admin password we have seen. So we're going to see this. Hey, copy this. This is your environment variable name, and you have to get the value from the secret. The name is going to be of the file is secret, of course. It's not actually a file name. It's actually a Kubernetes reference. It's usually with the file name also, but again, we need more theory. And the key is Mongo user. So use that, whatever that is. Okay, all right, super easy. The same is for MongoDB password, copy that. And this one is password. But there is one more of a variable which might create a little bit of the issue for a beginner. Because now we have to provide a server reference as well, that, hey, where this server is actually going on or how we're going to get that information. Copy that. The first easy thing is another environment variable. That means another value. Okay. But this doesn't need to come from the secret. It needs to come from the config file. So the rest of the values will remain same, that value from, you have to get it. But instead of calling it as a secret key reference, we're going to call this one as simply config map and map. And yes, this is exactly the proper name of it. Secrets are called secret, but config is called as config map. So config map key reference. What is the name of your config? So we called it as Mongo config. Really not the friendly. We should call it as just config, but you get the idea. We're going to call this one as mongo-config. So just a basic file name. Hey, take the value from the Mongo config. Okay, I'll do that. I'll go into Mongo config. And then the key is Mongo URL. Great. I'll come back and take the key of Mongo URL. You get the idea, how the application actually connects. So there we go. We have actually done with the deployment part, but there is one more thing which is remaining, which is service. We haven't opened up our application yet so that it can be exposed to the entire world. Okay. So this is API version will remain same, service remain same. Let's just call this one as web app. Again, the same problem comes to this one as well. To whom I'm attached with. I'm a service, but I need to attach with some deployment. Who is that deployment? That deployment is web app, and we can go ahead and use a selector. Remember, the selector is web app, so we'll copy this. The reason why I'm copying it from a special place so that you know where I'm referencing it. All right. Okay, so we call this one as metadata as, oops, my bad. It should be called as web app. Talking and working at the same time could be challenging. You get the idea. So web app service, selector is web app. Okay, all right. Now the ports to be opened up, TCP port, great. But my port is not this one. It is 8081. The target port, remember, the target port is coming up from here. This is the container port I'm targeting. I could have written that, but I want to show you the linkage. Okay. Now there is one more thing. Now this application currently is open up for internal network. This whole big thing, your database, your container, all inside it. But you want to access this outside of the world. Can do it right now. For this, you need to understand the concept of node port. So node port in the Kubernetes services, notice here there is a node port. So we'll just look for it, that where is this node port is thing. So there are endpoints and there's a lot of things you can study and read. Surely we will study them. Notice here, this is how they are saying that, hey, this is your client, your cluster IP, your backend, all this. There's a nice diagrams. There are a lot of nice diagrams. What I want to search for is node port. So there we go. And I'll just look for another one. There we go. Publishing your service. It says node port exposes the service of each node IP at a static port, the node port, to make the node port available. Kubernetes set up a cluster IP address the same as if you have it requested as a service type of cluster IP. So if you don't set it anything, it's a cluster IP. But the idea is cluster IP is only available to you. It's an internal network. To expose it as outside, you have to go for this. And another thing is this node port, you cannot actually go ahead and set any port on this one. They are saying as 3007. So node port doesn't work on any port as well. There's a specific range of ports as well. Let me go ahead and find out that. There we go. You have to provide a range from this many zeros and then 32767. So this is the only port range that you can expose your application to outside. Then from outside, you map it up to any domain name or any port. That's up to you. So we're going to go ahead and work on with that. So we are going to go ahead and say that I want to define one more of this, which is node port. And remember, this is how they are writing. Port, target port, node port, and this is what we are doing. Node port, and let's just call this one as 30200. Whatever makes sense, or you can just use exactly this one. A lot of people use this one because this is also mentioned in the documentation, and that's what we do. All right. Okay, a lot of configuration that we have written, but this is all what is required. In case we haven't done any typo, this should be all to deploy any MERN application. The advantage is now it's very replicable. And you can create so many of these configuration files for so many of the microservices and a whole lot of things. Just one configuration file, then deploy maybe you want to go for 100 container, you can just go ahead and say, hey, I want to have 100 containers of my application. It will scale it up. You don't have to do anything at all. So that is the advantage of it. But now, coming back onto the commands, so we're going to be using a terminal on this one. And where is my terminal? Let me go ahead, bring that up. Here we go. So we have installed all these things. Hopefully they are installed properly. Now, the first thing that we're going to go ahead and do is a minikube, and we're going to go ahead and start this. Now, minikube starting takes a little bit time because it goes ahead onto internet and downloads and pull off some of the base images because everything is containerized. If we would have deployed it outside in the cloud or something, then it's not minikube. It's actually an actual machines. One of them act as a control plane, other one works as a worker node. But the advantage is you install Kubernetes on just the cluster plane and just give it the point of the machines that here are going to be machine, which could be your worker nodes. And it deploys the container in all of them, of course, via kubectl, but we don't interact with the worker nodes much. So this is all it's going to take. And shouldn't take much of the time, depends on my internet speed, but let's give it a try. Probably, all right, still gonna take some time. So let me just go ahead and pause this. All right, it took some time, but I hope you can see what all has happened when we said, hey, minikube start. We installed it. At that time, nothing much happened. We just got the utility. But when we started, it gives us a lot of big container, which helps us. Notice here, using Docker desktop driver because I didn't have any other virtual machine or something. So it used my inbuilt Docker to containerize everything. And then it downloaded a Kubernetes, which is preloaded. Okay, that's great. Now it also created a Docker container. CPUs took 2 without even asking me, and a good chunk of memory. Yeah, it's a decent memory. And it also generated some control planes and RBAC rules and all of that. We'll not go much in detail of that. Remember, sun rises in the east. Okay, great. So we have now this, and that is it. That is all we do from here. We will not be interacting much with the minikube now because it has given us a kubectl, and I told you in the earlier time as well that all we got to do is interact always and always with kubectl, not with minikube. It's just an environment that was given to us. Now, rest of the things we'll be doing from the VS Code itself because all of our files actually are here and we don't need to travel to this directory. And a good thing is VS Code gives us an inbuilt terminal. So let's go ahead and work on with that. In fact, we can go full screen all of this. Okay. All right. So let me go ahead and open up my terminal first so that we can have some bigger fonts in the terminal. You can see that. So terminal. And the terminal should have some of the font. Just give me a second. It is good for you so that we can have terminal font. Terminal. Here we go, terminal. And all right, so now that we have a bigger font in the terminal, took a little bit while, but we can go ahead and get started. So minikube is running, up and running at this time. And all we got to do is always interact with the kubectl. And the next that we have to do is simply just ask kubectl that how many pods you are running. Remember, I told you pods, containers, big unit, yeah, just like that. So we're going to say and ask this, hey, just give me get pod. And that actually gives you all the pod. Right now, there is no resource because we haven't created one. The way how you create a resource is a step-by-step manner. The first is obviously dump up your secrets and config because I told you these are global ones. The way how to do it is just simply say kubectl and then you simply say apply. Apply is the most humongous command in the kubectl. It does majority of the work for you. And we're going to say -f to give it a file name. The first we want to go ahead and just go provide the secret.yaml. Now the secrets are being created. Told you, really, really simple after that. And then same apply command. Now let's go ahead and dump our config. These we called as mongo-config. Called it anything, just a file name, told you. And yep, config is created. Now let's create MongoDB because our application is dependent on that. So let's go ahead and call this one as Mongo app. So mongo-app.yaml. And notice here, it created a deployment and service. If this would not be a separate file, I would have first given it a deployment file and then a service file. Really simple. And then once this is all being done, I'm going to go ahead and say that, hey, now this is done. So go ahead and say webapp.yaml. I said that, hey, just create one replica of it. If I would have said 2, 3 or more, it would have created more of these pods. So it says web app-service is invalid. So spec port, node port, forbidden, may not be used type as cluster IP. So there is something wrong. So obviously there is a typo in this somewhere. So let's go ahead and work on with the web app. So web app.yaml. Let's see that where we are going wrong. And this is the good part of it, that it tells you all these things in advance. So 30. Let's try 100. So that is node port. Ports should be all good now. And we call this as web app service. And what's the name here? Oh, web app deployment. And yeah, that should be all good. Let's go ahead and try this out. Probably I mistyped the port or something. Web app service is invalid. Okay, let's see that where we are actually making the mistake. Okay, let's first try to run this again one more time if this works. And it says no, spec.port is forbidden. Let me just go ahead and debug this quickly. All right, found the bug. It was something that I missed actually. So it's really simple, just about the selector. We actually missed it out during the documentation in our talk. That here in the spec, there was a type of node port that we have to mention. Otherwise, the default is cluster IP. But again, no big deal, happens with the best of us. So there we go. We have got this one, and selector, it should be on the same indentation level. So I just saw it here. So selector, and then here it is. So selector, we should actually make it above the selector. My bad. There we go. So we have to mention the type as node port, and then you can provide this information. And again, I checked the case sensitivity twice again before going with that. So you get the idea. Okay, no big deal. Let's go ahead and try this out. And there we go. Finally, we have got the deployment and the service being spinned off. Okay, no big deal. We have gone through with that. We have created all these things. Now let's try how many pods we actually got. So the same command, we can just hit the up arrow key a couple of times and get pod. And notice here we are getting the pod of Mongo deployment, web app deployment, and some of the unique IDs with that. Now, by the way, you can actually provide this option, which is really, really handy option of -o and wide. This is really a common option that you want to get more information. So you provide this -o wide. I have bumped up my font. That's why this actually shrinks to the next line. Usually we want smaller font, bigger terminal so that we can see all of them in one line. So that is better opportunity there. Okay, you can also get anything. Right now we have got the pod, but you can get anything. For example, instead of the pod, you want to go for secrets. So we are going to go ahead and say, hey, give me all the secret. So there we go. And it gives you a secret that, hey, here is a Mongo secret, opaque type. The data is 2 because we store 2 values into it. And you can also go ahead and grab a config map. So we can go ahead and say config map. And the config map is going to come up. This is default. It's a certificate that is provided by Minikube. We'll talk about them later on. So the Mongo config is available up here. And you can also go ahead and say get services. So we're going to go ahead and say kubectl get svc. And it gives you all the services. Kubernetes is running, Mongo service is running, and web app is running. The entirety of the Kubernetes is running on this port. So that is the basic of it. Now, the only command that sometimes you are going to see with the Minikube is to get the IP. So we can go ahead and say Minikube and IP. This gives you the exact IP that where this entire Minikube is running. And this is sometimes important to make sure that we listen to our app. But there is a catch here. In the recent update of this Minikube, although everything is up and running, we don't have any problem and we can just look for it. Notice here, our application is listening on port 8081. I can go ahead, copy this, move back here, and I go ahead and say, hey, this is 8081. You won't be listening anything. This all has to do is how Minikube has updated itself in the recent days. And in order you want to expose this application and really want to check it out on your local machine, because Minikube is all about local, there is a new command that Minikube actually gives us is what service you want to really expose it. Although we have given the node port and stuff, that is still compulsory, but you have to clearly mention this Minikube that, hey, this is the service. I want to really see what is happening at that service. So for that, the only command that you have to take through is Minikube and then have to say service. And notice here, there's a lot of things going on. you have to mention the service name. In this case, my service name is, I can grab from here after getting SVC, copy that, and we'll be saying paste that. Once you do this, hit enter. Now notice here, this is starting this. It is going to open this up as a default. Now it will open this up. Now this is opening up on any port. This doesn't really matter. This is how you actually get your application. Now it says Docker drivers and all of that. So this is starting a tunnel to my application on the same port 3100 and whatever. It is redirecting it onto my this URL, and there we can actually go ahead and use that. So right now this is not working. Probably I have done some mistake in that. So let me go ahead and fix it and see where the problems are actually there. All right, so after small debugging, the session is up and we are able to deploy our app. Let me show you where I made a mistake, and this was an honest mistake. I actually did it. This was not intentional. I actually forgot to discuss a little bit about why we are having this metadata. We are going to discuss about them in the upcoming videos, but metadata is something which is almost you can compare with the class name. So whenever you have built any application, you write your class name and you export that class name. It doesn't really matter what your file name is. And same I was trying to show you, but actually that skipped my mind. So we call this as mongo-config in the Mongo config, and we call this as metadata as Mongo config. Same goes here as well. In the secret, we called it as Mongo secret. That is actually the file exported name, but we called it as secret. So in the talks, I actually went up and just called this one everywhere as just the secret, just the secret. Shouldn't be doing that. The name of the file, the meaning that what I wanted to convey in that is, by the term saying that the file name, it is a configuration created inside the kubectl or the Kubernetes. What are we going to call it? I just thought that we are writing it as Mongo secret, but we actually wrote it as just secret. So the actual reality is we should be calling this secret reference as Mongo-secret. Only reason for that is because in the secret, we are calling it as metadata as secret. If we would have called it as just the secret and nothing like that, then it's the configuration name is secret. So that is the mistake that we did. Once I fixed up the mistake, I flushed it all out. I removed all the deployment, everything. I'll show you how to clean up that as well in a minute. And that was the mistake that we did. I am pretty sure you are also going to do that. The honest YouTube videos where I don't hide my mistakes, I in fact show you so that you learn the debugging process. All right. So this is the basic and we're going to work with that. So let me show you that how it actually went up, and let me show you the commands actually to remove all of this as well. Rest of the commands are same. And in fact, I'll write all these commands in a text file so that you can also learn more about it. The way how you actually remove all of the things, first you need to learn about that. So we have to say is kubectl, and then we have to delete all the things. So just say delete, and let's just say you want to delete all the deployments. So this is you should not be doing this into a production environment, but here we are just doing it. So let's just say we are removing all the deployments. So we're going to say --all, and then it will remove all the deployments. Similarly, we can go ahead and say, hey, I want to remove all the service. We're going to go ahead and remove the service. And similarly, we can go ahead and say, I want to remove secret. So it will remove all the secret just like that. And remember, notice here what it is removing is Mongo secret. I'll walk you through all these things just in a minute. We'll focus more on the command output this time as well. What else we have? Config map. So we're going to say config map. There we go. Now let's go ahead and deploy it one more time so that we have fixed the bug. And again, hope everybody remembers the bug was really simple. In both the files, web app and in the Mongo app, we were referring to the file as just the secret, but we should be referring it as Mongo secret. The reason for that is in the secret file, we are providing a metadata as Mongo secret. So again, the reason why I'm telling you all the theory that how I was able to catch the bug, because it will happen to you as well. And once you understand the process and see the bug, that's where the experience counts. So let me go ahead and run this. So our kubectl is up and running. We need to apply. So first and foremost, we go ahead and say kubectl. We want to apply and -f. The first file that we are providing is secret. And notice here, it is creating a secret with the name of Mongo-secret. So this should be referred everywhere. And that is the mistake. We kind of skipped through it. So, but anyways, you get the idea. Now, the next file that we want to apply is the config map. Feel free to call it anything. We are going to call this one as Mongo config. That is the file name. But surprisingly, or just a coincidence, that in this case, we created a metadata as Mongo config as well. But this file name could be Superman-config, All that matter is metadata. It's almost again, same example, class that you're exporting. All right. And then we go ahead and apply for the Mongo. So Mongo app. So we're going to say Mongo-app. And we apply that. So notice here, deployment and the service, they also have their metadata. So the deployment, we call this as Mongo deployment, this one as Mongo service, but we could have called it anything in the metadata. Similar to this, we are going to have our web app. So we're going to go ahead and call this one as webapp.yaml. And again, all we got to do is get a minikube IP, but the same problem remains. So minikube IP, we although get this IP and our port is listening on wherever web app is listening on. In this case, it's listening on 301.0.0.2.0, whatever we have mentioned. So I'm going to go ahead and just copy this. And if I go on to the browser on port 301.0.0, it doesn't listen to this on this port still. But if I go back and try to run the same command, remember I told you about this command that is recently being updated in the minikube, which is expose the service, whichever the service you want. And we just find out that we call this one as web app-service. By the way, in case you don't want to get it or don't know how to get it, all you can do is just ask kubectl that, hey, get node, and can -o a wide onto this one. So notice here, this is not readable. This is not readable. But again, we can actually get all the pod. That would be, I think, better. Get the pod. There we go. So we have the web deployment and the Mongo deployment. And similarly, you can get the service. So let's just go ahead and get the service. kubectl get svc. And there we go. So the service that is we want to access is the web app service. Copy that. And then we can go ahead and say minikube service. And we want to get this service up and running. And once you do this, this actually creates a tunnel. And this time we are able to log in into database, and we can go ahead and create a new database, and we can actually interact that. So your web application is done. So I hope you got the idea that how we were able to debug it and actually solve this problem. I'll actually add that as a side note in the video itself so that less people actually face this problem in case those who don't want to experience the debugging. But this is the most important part. Debugging is the most important part. So I hope you get the idea that how we can deploy the MERN app directly into this. But this also brings us our interest into Kubernetes, that why knowing about metadata is important, why knowing about the node port is important, why knowing about the services, deployment, secrets, config map. There could be more services that are offered. Right now for MERN app, these much are required. So we got the idea of it, but maybe there are something else. Maybe you want to deploy the DNS also. So there could be more. Maybe you want to roll out an update. So how to do that and how to achieve that, that is where the Kubernetes actually comes into the picture. I hope via this video, I have given you enough of curiosity that you can hit that subscribe, as well as can read and learn more about Kubernetes. That was the goal. That is it. Let's go ahead and catch up into the next video. Thank you so much.